welcome to the Tech Nectar podcast. For this episode, I'm going to describe the poster presentation I did in American Psychological Sciences Conference in May of 2019. This poster was a presentation of some informal validation studies that I did looking at the emotive insights consumer grade EEG ability to identify different cognitive states for me doing various activities and for students in two different educational environments. So this project got started when I first looked for a way to have my students experience neuroimaging. And since I didn't have access to an expensive fMRI machine, which I'm actually much more familiar with because it was fMRI research that inspired my dissertation, I wanted something for students to be able to experience in real time. And so I looked for things that would be cheap enough and portable enough so that we could experience that in the classroom. At first, I looked at maker websites to look for ways of putting together my own EEG. And although I've found some plans, none of them were established enough for me to be confident that I could pull it off. However, I remembered seeing the device that Tan Lee presented in her TED Talk in 2010 and decided to look up how that project was progressing. And I found out that she had a very inexpensive EEG system for about $300. So I decided to write a grant to get one of these systems and to see if my dreams of showing my students neuroimaging in real time was possible. After purchasing one of these devices, I realized that they had an app that could connect to an iPhone and process the brainwaves into their algorithmic guesses of what was going on in somebody's mind. So they have a measure of stress, a measure of excitement, a measure of engagement, a measure of focus, a measure of interest, a measure of relaxation. And since this is a brand new thing to me, I wanted to see if these measures actually could be validated in real life situations. So I wore an emotive insight during different activities. The first activity that gave me some insight into what the emotive insight could do was trying meditation. A couple years ago, I had fainted in the middle of telling my students how an action potential, the firing of a neuron, happens. And I had thought that it was nutritional disorder like hypoglycemia or something like that. But after being diagnosed with basically stress fainting, vasovagal syncope, I realized that I had to find a way to de-stress my life. So take stress out of my life, not to de-stress it, as in make it more stressful. And one of the things that I tried was mindfulness meditation. I thought this would be a good opportunity to try the emotive insight and to see if the EEG could detect the cognitive state that I was going through as I went and tried mindfulness meditation. And as you can see with the graphs that my emotive could produce, during the meditation that their measures of engagement went up during the meditation session, and the measurements of stress went down, the measurement of focus went down, the measurement of excitement went down, the measurement of interest kind of stayed stable throughout the entire session. And I don't know what the measure of relaxation was doing, but it went down for the entire meditation session. The next mini experiment that I did was to wear it during a lecture, a cognitive science or a psychology colloquium lecture. And as kind of like a test case for what my students might experience during one of my lectures. And throughout the lecture, you can see that there were parts of it that seemed to spike the engagement measure. Especially when I was like thinking about questions that I might ask the presenter. Other my emotive measures also spiked at the same time. So you can see that their measures of focus kind of can correlate with the measurement of engagement. Another activity that I did while wearing a emotive was playing video games. So I'm a big fan of the idea that video games could be used as teaching tools. So I wore the emotive during sessions of gaming. And one particular session was enlightening because it was interrupted by my family, who needed my help holding a poster down. And so I start the session out and I'm playing this video game. Then I get interrupted and I have to like interact with people in real life. Then I go back to playing the video game. And then something went wrong with the poster, so I had to go help out for just a little bit more. And then I went back to playing my video game. When you look at the graph for this session, there are at least 2 different cognitive states that emotive were able to extract out of my keen. And while I was like interacting with people in real life, you have high excitement and interest. And both of those seem to peak at those points. And then the other measures kind of dip down. So the engagement and the focus and the stress and everything else. So this little mini experiment made me realize that this device could really show different activities that people are doing. And there are distinct patterns that we should be able to pick up using EEG. So, given that insight, I wanted to look at more what exactly are the patterns that we might want to look for. So I did a test of this idea by having one of my students listen to my lecture in real life, and another student listen to the same lecture as a recording because they were unable to make that meeting and needed to watch it anyways as a recording. And then I had a student do an internship with me, or an independent study where they took the graphical data that my emotive has as an output and turn that into quantitative data that could be then statistically analyzed later. This is a painstaking process, and I would not want to do this again. This independent study person took segments of the lecture and visually averaged my emotive outputs for each one of the factors. The resulting output for both the person who was watching in the face-to-face or real-life session and for the person who was watching later on a video can be seen in the graphs in the middle of the bottom of the middle of the poster. But just looking at these graphs, you might be able to tell lots of different things. So the person watching it in the video, you can tell that towards the end of the lecture, there was a spike in a couple of the measures. And I had interviewed this person, and they actually mentioned that they got more into the lecture as it got on. So that was a verbal validation that there was something measuring their conscious interest in the topic that correlates with the measures that we see. And when we put this into a exploratory factor analysis, we find some interesting patterns. So one of the things that we added to the factor analysis was I was interested that there were periods of time where there were more fluctuations in the measures than at other periods of time. And I think those periods of fluctuation were interesting to me. I think that I had an instinct that those periods were something that were distinct from any state of cognition. So I put those into the model also. Factor analysis using the statistical package Unimult, what we find... Oh, and this particular analysis was Promax using Verimax, which means that it's using a non-orthogonal factor analysis, meaning it's trying to find factors that might even correlate with each other a bit, but are distinct in themselves. So how do all of these measurements connect to each other? And what we find is that there are basically three different common patterns. So one of the things that they have all in common is that engagement, stress, relaxation, and focus seem to all correlate together. So this kind of makes sense, because when we looked at the graph in my video game playing states, those are the measures that do indeed correlate together. They all went down together. And because of my experience with meditation and listening to the lecture, I equate these measures to times of contemplation. Like, you might not actually be actively doing anything, but remember, engagement went up when I was thinking of questions to ask a presenter. And it went up when I was doing a mindfulness meditation session. So I turned this first correlative pattern, this first factor, as a contemplative factor. The second factor showed that my impulse to pull out periods of time where there were lots of fluctuation was actually a good one. And these periods of fluctuation were a distinct pattern from the actual absolute value of those 4 factors. So when engagement and stress and relaxation and focus were correlating together, it didn't necessarily correspond to when they were changing. So when they changed together. So the second factor seemed to correspond to periods where engagement, stress, relaxation, and focus were changing together, but not necessarily in the same direction. So I termed the second factor transition, because it corresponds to periods of time where there was change happening in these factors. And then finally, we have a third factor where interest, especially, and excitement were highest together. And these actually corresponded to periods of time where interest and excitement had high fluctuations, high difference scores, meaning that there was lots of changing of these scores during these periods. And this corresponds to my observations of myself during the time I was wearing the emotive while playing video games and got interrupted. And while these interruptions were not particularly engaging, I was just helping frame a poster, and I wasn't like really excited or anything. I was doing something active. And so I think this factor corresponds to participation, where people were actually doing something in real life. And so after doing this factor analysis and pulling out interesting patterns in the data, I wanted to compare how these different patterns interacted between the person who was watching a video of my lecture and the person who was in the lecture room as I was lecturing. And what I found was a little bit surprising to me, but after some analysis, it shouldn't have been. What I found was that the factors of contemplation and transition were actually higher for the person who was watching the lecture. They weren't forced to participate, but they were thinking about the lecture, and there were more times where maybe they got distracted or had to think quickly or changed their mode of thinking, even though they weren't in a spotlight. However, the measures of participation, of actively doing something, was higher in the condition where the person was being lectured to face. And I remember this person maybe asked a couple questions during the lecture, but it wasn't a constant engagement, constant questioning. So that should be taken into account. Just being present with somebody seems to be a distinct cognitive state that I think is important for learning, but is not the end all be all for understanding the lecture's content. Perhaps I don't have scores from these students to see what exactly they learned from these lectures. And perhaps in the future, correlations between these different cognitive states while listening to lectures and the information that students retain might have to be done. And in the end, the thing that I really got from this experiment was that it is indeed possible to use these relatively cheap and portable EEG devices to get objective data on how students are responding to lectures, and using these devices in more naturalistic settings would be possible to get meaningful data. Just last week, I saw that there was a company that's teaming up with some Chinese schools to use EEG to evaluate students on their ability to pay attention. This is a little bit disturbing because the framework that it's the student's responsibility to pay attention and to modulate their brainwaves into a certain pre-prescribed cognitive state presupposes that we actually know the best way for students to learn. And I don't think we're there yet. So using these measures as a bludgeon to get students to learn more might actually force them into non-adaptive cognitive states. For example, it might force them to be more participatory, but take away some of that contemplative processing that might also be important in retaining information. I remember that in high school, my English teacher gave extra credit for people to participate, and I regularly got over 100% on my evaluations because I enjoyed participating, and the extra grading just made it more likely for me to dominate the conversation. So much more thought has to be put into how exactly to use these measures to improve student performance rather than assuming that we know everything there is to know about how students should learn. However, measurements like this might be a better opportunity for us to study the process of learning as opposed to using students' conscious evaluation of professors and or classes, which we know are highly susceptible to student biases. For example, classroom evaluations of female instructors are consistently lower than male instructors, even in situations where students demonstrate better learning. This pattern has also been shown in situations where students didn't like the professor's political persuasion, sexual orientation, or race. These are the factors that should not matter when it comes to learning, and an objective measure that doesn't rely on these biases might make the research into learning clearer. Well, thanks for listening to my presentation. As always, if you like the theme music, go check out my friend Galen Lee and her Tiny Desk Winning music.